In this video, I will show you how to do the problem number 16 in the 7th edition of Storch Calculus book, section 12.5. Okay, this problem have two parts. Okay, now let's look at the first part. First part, number 16. Okay, the first part, we're asking to find the parametric equation of the line that contain a point 2, 4, and 6, and also perpendicular to the given plane. This given plane equation is like this: x minus y plus 3z equal to 7. Okay. So we have been given a plane. Okay. This plane's equation is here. Okay. Now we're looking for a line. This line perpendicular to the plane, at the same time contain a point 2, 4, and 6. Okay. So as you know, to find the equation, parametric equation of a line, we need to its form is always like this: x equal to x naught plus at, y equal to y naught plus bt, and z equal to z naught plus ct. Okay. X naught, y naught, z naught here is any point on this line. Okay, and the ABC here is a vector, any vector your line parallel with. Okay, so any vector your line parallel with, ABC. As long as you can find those two things, you put them in, then you're done. Okay, so for this problem, and obviously your x naught, y naught, z naught is easy to find, which has been given, right? They said contain points, throw a point 2, 4, and 6. Okay. So next we need to find ABC, a vector your line parallel with. Okay. What do we know? We know this line perpendicular to this given plane. Okay. In general, any equation for the plane can be written like this: a times x naught minus a times x minus x naught plus b y minus y naught plus c z minus z naught equal to 0. Okay. Here x naught, y naught, z naught is any point on the plane, and ABC here is ABC here is a vector perpendicular to your plane. Okay, so now they give us the equation of the plane is here: x minus y plus 3z equal to 7. Okay, what is a here? A is a coefficient of x, b is a coefficient of y, c is a coefficient of z. So they give us the equation x minus y plus 3z equal to 7 means they give us a vector 1, minus 1, and 3. Okay. What is this vector? 1, minus 1, 3. That's exactly your ABC here. That means this is the vector, your plane perpendicular. That's exactly the vector we're looking for, because our line parallel with that. Therefore, our ABC here, that will qualify our ABC for our line. Okay. Let me say that again. 1 minus 1, 3. That's a vector like this, your plane perpendicular with. And this vector will be exactly one we're looking for, your line parallel with. Okay. So once we have those two things, we can write down the parametric equation. Okay. X equal to x naught, for this case is a 2, plus at, which is 1 times t. Y there is y naught, which is a 4, plus bt, b is a minus 1, so minus t. Z here is 6 plus C is 3t. Okay. So we answer the question of the first part. We find the parametric equation of a line. This line is through a point 2, 4, 6 and perpendicular to the given plane. Okay. Now let's do the second part. Part B. Okay. The part B is we are looking for the intersection points of the line. We're looking for this point. Line intersect a plane. Okay. What do we mean intersection of the line and the plane? That means this point must be on the line at the same time must be on the plane. Okay. So we know anything calculated by this way will be calculated by this. Anything calculated by this way for given t will be on the line. Okay. So what we need to do, substitute x, y, z here to the equation of the line. Okay. Equation of the plane, which is x minus y plus 3z equals 7. Okay, so what we need to do, replace x here by 2 plus t. 2 plus t. Replace y there by 4 minus t. Replace z there by 6 plus 3t and equals 7. Okay. So by doing so, we're looking for the points on satisfy the equation of line and the equation of the plane. Okay. So you solve for t. So we add all the t together, we got 8t and 7. You have 2 minus 4, give you minus 2, plus 18, so give you 16. Okay. So 7 minus 16, you solve that, you got your t there equal to 9 over 8. Okay. Right? Okay. Then you put it back in this equation of the line. You will get your x there equal to 2 plus 9 over 8. Your y there equal to 4 minus 9 over 8. Z equal to 6 plus 3 times 9 over 8. Okay, and you will get a point, okay? And this point, I'm going to write here. You can do the arithmetic. 4 minus 9 over 8. 6 plus 3, 9 over 8. You got a point. First of all, this point will be on this line because for any t, they will be on the line. At the same time, they will satisfy equation of the plane. So this point will be your intersection point.